I assume that you supply the data.
Well, I help supply the data. The data is mostly supplied by our science and observation teams. And the challenges the Service Hub, as I mentioned earlier, is to make sure that we can connect that diversity of demand that Chris and Dave mentioned. So how do we do that? We kind of came up with three different patterns by segregating our data sets into three big buckets. So we have what we call object data, which is for the demand systems that are more interested in the big data sets and as close as possible as the data producers. Finally, we have what we call features, which are points, either points in time or points in space, or both. And they have also their own pattern that accounts for the diversity in terms of non-functionals for those data sets. What we managed to architect in AWS was three ways of delivering those three types of data sets by minimizing commonality. So, for example, to deliver the objects is quite simple. So basically, it's an S3 layer with a very simple API gateway Lambda front end. Then to deliver the data sets, we do heavy use as well of Lambda, but to then break the data in S3 into more efficient storage. And finally, for the feature data, for the point data, we have object stores, we use things like DynamoDB and Redis to be able to accommodate with the different queries, geospatial queries and so on that happen.
So when it comes to those big chunks of data, how do you handle them on your website?
Well, quite frankly, we don't want them. So if I can talk a little bit about how our app works as an example, we have about 9 million users of the app. So if you can imagine again, up to 9 million people at any one time, if there was a nationwide warning, making a request for data by opening up the app and making a request for data. Each user of the app has 2 or 3 sites they're calling for. So each app instance calls for 1 or more unique sites. Very difficult to cache. That data set changes hourly.
Yeah.
So each of those 45,000 locations is updated hourly. So they'll make a request for data for 1 or more specific locations, boom, 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 hitting us at the same time or very close to the same time. So we need to be able to have very, very fleet of foot services that can serve up that data very, very quickly in each of it being unique.
Arminio, you talked about some of the services you're using for storing and distributing data with Service Hub, and they sound very cloud native. Was the platform originally designed for the cloud, or has it been migrated from on-premises?
It was originally designed for the cloud, and I think that's part of our current success is based on that. As Chris mentioned, there are several ways to scale in AWS, as you know. And we were given the time and the space to re-architect our workloads to make use of the cheaper, easier ways. I mentioned Lambda, I mentioned API Gateway. If we had shorter time in the beginning, so we were given roughly 6 months to re-architect those workloads. If we were given 1-2 months, we probably would have done a lift and shift exercise. And we would probably have ended up with EC2 or containerization on Kubernetes or ECS. That would have been okay, but it wouldn't provide that infinite scalability that Chris mentioned. But right now, we don't have any servers. And actually, my team has a policy, an unofficial policy of not instantiating any servers. What does that mean? It means that it's you guys who take care of all of that scalability. So when we have one request every few minutes, it's Lambda that serves that request through API Gateway. But at the same time, when we have 3 times 9 million requests, as Chris mentioned, it's still Lambda and it's still exactly the same pattern, the same architecture and so on.
So how did you and your team find the sort of change of culture necessary to go from sort of thinking about building platforms on servers to thinking about sort of building them with Lambda and event-driven architecture, that kind of thing?
It's a process. I think the secret in that process is prototyping as much as you can. You need time and you need space. So you need time because it takes time to go from a Linux server-based mentality with Spring Boot Java applications to a Python Lambda where you need to think about other aspects like infrastructure as codes, deployment pipelines and so on. That takes months. Don't expect for a traditional Java developer to learn that in a couple of weeks, especially a team, when you want everybody to learn, allocate at least 6 months to do that.
Yeah, I think that's where getting into, say, total cost of ownership is really key here. It's so easy to get driven by this is the quickest thing to get you to a place, and then that ongoing cost is so hidden often by a lot of organisations, and I think we've been caught with that before, and I think showing that to our business customers about where we can reduce that pain later, I think that's really valuable. I think it's interesting that you guys have talked about serverless as a way of dealing with scale, and absolutely it is for you guys. For my area, we're also sort of serverless first, but we're really key on having data sets that are, a lot of stuff that we do is really time critical and doesn't happen regularly. So a chemical spill is not something we can predict is going to happen, but we can run a model when that does happen to produce some dispersion, atmospheric dispersion models that people use to know where that cloud of gas or liquid is going. And that happens at a moment's notice and we can't predict that. So serverless is ideal for that because when nothing's happening, it's not costing us anything. And that's really key, especially in government where this is taxpayers' money paying for stuff we don't want to be paying for tin doing nothing. So serverless for us is really about that kind of cost side. The scale, that's fantastic too, but that's less of an issue for us. Obviously much more an issue for you two. But it's that TCO kind of show we can show. If we do it like this, it's going to cost us a bit more up front because we're not just going to ping this thing straight over to an EC2 box and do what it used to do. It'll take a bit longer to dev, but post there, it will cost you virtually nothing to run it. And it is virtually nothing. In fact, it is nothing if nothing's happening.
One thing I'd like to mention when Armio talks about the space to prototype is that different teams have been given the autonomy to prototype their own solutions for their own problems. So if we were building an on-prem solution, what the tendency is to find a one-size-fits-all approach for the organisation that we all then have to conform to. We have to make our solution fit the boxes that we bought, fit the tin that's in the IT hall. So the solution that Arminio's put in place was rather serverless to serve up his needs. It's not the same solution we're using in our weather cloud. So we've been able to take a different approach. We're prototyping a different problem. So we can select from a wide range of solutions that the team thinks is the right one and go down a different way with the full blessing of the organisation to do so and come up with a more pointed solution that better meets the needs of the customers that we have.